181754, and my partner name is Muhammad Azri bin Hilmi, metric number 182508. So for this assignment of computer architecture, we choose topic of mapping function. Mapping function is included in the lecture 3, memory. So as the cache line is less than the memory blocks, an algorithm is needed for mapping main memory blocks into cache line. Further, a purpose is needed for determining which main memory blocks currently occupies the cache line. The choice of the mapping function depends on how the cache is organized. So, the first is there are 3 methods for mapping addresses to cache location. The first is the direct mapping, which is the search the entire cache for an address. Second is the associative mapping. Each address has a specific place in the cache. And the last is the set associative mapping, which is the address can be any of the small set of cache location. Next, the first method is the direct mapping. This is the simplest technique as it maps each block of the main memory into only one possible cache line. The mapping is expressed as the I equals to j modulo m, where I is the cache line number, j is the main memory block number, m the number of lines in the cache. Each location in RAM has only one specific place in the cache where the data will be held. Consider the cache to be like an array. Part of the address is used as index into the cache to identify where the data will be held. So next is the addressing for direct mapping. The lower log2 in bracket line size bits defines which byte in the block which is the located in the rightmost side. So the middle side is the number of line and the left side is the text. So there are 3 sides, which the left, middle and right. The left is the text, the middle is the number of line, and the right one is the offset or the word. So this is the cache constant, which is very important to understand the concept. First, the cache line or the line size is equals to the number of lines. Then the line size is equals to the bit of the offset, and the number of line equals to the bit for cache index, and the remaining upper bits is the tag address bits. All of these can use to calculate the parameter. So we take a look at the example. Assume that we have 32 bits addresses for 64 bytes line. 64 bytes line equals to the offset of 6 bit, because 2 power of 6 equals to 64. Then we have the size of cache is 32 kilobyte. So to find the number of line, we divided the cache size with the byte line. So we gain the bits is 512. Using that 512, we substitute into the formula of number of line, so that we can find the middle one, which is log2 in bracket 512 will equals to 9. That 9 is used as the bit for the line. So we have the offset of the word of 6 bit, the line, the middle, the 6 bit, and the remaining text is 17 bits. Okay, next is the associative mapping. Associative mapping overcomes the disadvantage of direct mapping by permitting each main memory block to be loaded into any lines of the cache. In this case, the cache control logic interprets a memory address simply as a tag and a word or offset field only, meaning that the associative mapping only have tag and word. So the tag uniquely identifies the block main memory. Okay, that from the figure below, there are 2 sides only, which is the tag and the offset. So the left part is the offset and the remaining one is the tag. So That's all for me. Thank you.
My name is Muhammad Azri bin Helmi. My metric number is 182508. Okay, today for the as you know, we are doing mapping function for this computer architecture assignment. As previous video, my partner Adam doing about the direct mapping and associative mapping. So as for my part, I'm doing set associative mapping. It is the compromise of direct mapping and the set associative mapping. So it kind of combining the both operation and to make the set associative mapping operation. Okay, these are the terms that we need to use in this mapping. The first term is cache, set, line, block address, and mapping. Alright, as for the set associative mapping, the cache is divided into a number of set of line. Alright, in each set there is fixed number of line. As example, in the first set there is 2 lines. Alright, the number of lines is same for the next set. Alright, I show you the figure. The first set is divided into 2 lines, second set also 2 lines, up to the fourth set. In this set, there is 2 lines. It is as 2 ways associative mapping. It depends on the how many lines in each set. If there is 4 lines, it is called 4-way associative mapping. Alright, there is calculation in this mapping to calculate the number of lines in the cache and the set number. For the number of lines in the cache, we need to know the number of sets in the cache, also the number of lines in each set. So the cache is one building block of data, and in each block there is a number of set, and in each set there is a number of lines. So we need to multiply the number of set and number of line to know the whole number of lines in the cache. Alright, to calculate the set number, we have to know the main memory block number and the number of sets in the cache. The formula is J modulo V. We address the J as the main memory block and V as the number of sets in the cache. Alright, I'm going to show you the set associative mapping. It is combined from the memory address. In memory address we have the tag, set, and word. Alright, the value from the memory address is compared from the cache data, and then we have to match, either it is matched or not. After all the things process have been through, it's going to deliver to the output part. Alright, in set associative mapping, the address are mapped by tag, set, and word. Alright, for X, I will call as X ways, because we don't know, we are going to make either 2 or 4 or 8 ways associative cache. As for the calculation, to know how many tag, set, and word there is in bits, we have to calculate it one by one. Alright, to know the whole bits in the cache, I address tag as T, set as D, and word as W. We have to sum it up, and we calculate as 2 at the power of all of them. Alright, size of tag is I address as T bits, and then the block size we calculate based on the word, how many bits on the word part. Alright, the number of blocks in main memory is the combination of T bits and D bits. The number of lines in the set we measure as K from the previous. Alright, the number of sets is the 2 of power of D bits, I address as set, and then the number of lines in cache is the K multiplied by the number of sets. Alright, I also provide an example to make the viewer understand more. on the set associative mapping. Alright, the example is a computer uses 32-bit byte addressing. The computer uses a two-way associative cache with a capacity of 32 kilobyte. Each cache block contains 16 bytes. Calculate the number of bits in the tag, set and word field of a main memory address. Alright, for the solution, the word bit we can know by the information given. It is said as each cache block contains 16 bytes. Alright, 16 bytes in cache block, which is 2 to the power of 4. So it means by 4 bits word. To know the bits in the set, it also given information in the example. Each set contains 2 cache block as it 2 ways associative cache. So it is combined of 32 bytes. The cache size is 32 kilobyte. So we can know the number of set by dividing the number, the cache size and the cache block. So it is 32 kilobyte divided by 32 bytes. So we can get 1000 sets in the cache block. 1000 set equal to 2 to the power of 10. So we can know the set bit is 10 bits. Alright, the whole bits given in the example is 32 bits. So we can know the rest of the tag is 18 bits by subtracting 32 bits to 4 tens. So we can get the 18 bits in the tag. So that's only for me on the set associative mapping. Thank you.